Imagine standing at the edge of the world's most ferocious storm, where the air spins with a power so fierce it could strip paint from buildings and uproot entire forests. Hurricanes are not just weather, they are unstoppable forces of nature shaping history, lives, and the planet itself. This is their untold story, raw, dramatic, and relentless. Hurricanes have fascinated and terrified humanity for centuries. Massive tempests born in tropical oceans, with winds faster than a speeding train and the power to reshape coastlines. But beyond their destructive force lies a story of science, survival, and the enduring bond between nature and mankind. At the end of this journey, we uncover how hurricanes form, what fuels their fury, and how their increasing intensity reflects a changing world. From historic storms that altered civilizations to the science that predicts their every move, this video reveals the awe-inspiring saga of hurricanes like you've never seen before. In the vast expanse of the tropical oceans, something extraordinary takes shape, a colossal force of nature that will soon unleash its fury on all who live in its path. This is the birthplace of the hurricane, a natural phenomenon forged by the delicate interplay of warm waters, the atmosphere, and Earth's rotation. Understanding how hurricanes are born reveals not just the mechanics of the storm but the intricate balance of forces that drive our planet's weather systems. The story begins with the sun's relentless energy warming the surface of tropical oceans. When sea surface temperatures rise above 26.5 degrees Celsius, 80 degrees Fahrenheit, an environment ripe for hurricane development emerges. Warm water acts like fuel, evaporating and saturating the air above with moisture. As this moist, warm air rises, it cools and condenses into clouds and rain, releasing latent heat, an invisible but powerful energy source that warms the surrounding air and causes it to rise faster. This process creates a cycle that draws more warm, moist air upward, setting the stage for a towering storm system. But for this system to grow into a hurricane, several other conditions must align. One critical factor is the Coriolis effect, a result of Earth's rotation. This force causes moving air to turn, imparting a spin to the developing storm. Without this rotation, the warm moist air would rise but lack the swirling motion to organize into a coherent vortex. Interestingly, hurricanes cannot form near the equator because the Coriolis effect is too weak there to produce the necessary spin. This explains why hurricanes typically start forming between 5 and 20 degrees latitude in both hemispheres. As the storm's rotating cluster of clouds grows, a core of low pressure forms at the center. This low pressure acts like a suction pump, pulling in surrounding air at the surface, feeding the storm with more warm air and moisture. The faster the air converges, the lower the pressure becomes, speeding up the cycle and intensifying the storm. This feedback mechanism is known as positive feedback, a process that fuels the storm's rapid growth and increasing strength. Within the swirling storm, a remarkable feature begins to emerge: the eye. The eye is a relatively calm, clear area at the center of the hurricane, often surrounded by the eye wall, a ring of towering thunderstorms where the storm's most intense winds and rain are found. The eye forms because air is drawn upward rapidly in the eye wall, creating a drop in pressure and temperature in the center. As air descends in the eye, it warms and dries, resulting in the curious paradox of tranquility amid chaos. Hurricanes are nature's most efficient engines, converting heat energy from the ocean into mechanical energy, wind speeds that can exceed 150 miles per hour in the most severe cases. As long as this heat source persists, the hurricane will continue to thrive. However, hurricanes are finite creatures. They weaken when they move over cooler waters, encounter dry air, or hit land where the supply of warm, moist air is cut off. But the power of a hurricane at its peak is awe-inspiring and terrifying. Hurricanes are capable of dumping trillions of gallons of rain, causing catastrophic flooding. Their destructive winds level buildings, topple trees, and hurl debris with deadly force. The storm surge, a colossal wall of ocean water pushed ashore by hurricane winds, wreaks havoc on coastal communities, inundating homes and infrastructure. The birth of a hurricane is thus a tale of energy, dynamics, and delicate natural forces aligning to create one of the most formidable phenomena on Earth. Far from a simple storm, the hurricane is a complex system born of fire and water, the sun's heat driving the ocean's evaporation and Earth's spin turning chaos into spiraling power. Yet, as humans have learned more about hurricanes through years of observation, technology, and scientific inquiry, we've come to understand how often these beasts form, how they behave, and how we might better predict their paths to save lives. Still, despite our advances, many mysteries remain. How exactly will a warming climate alter the birth and fury of these storms? Will hurricanes become fiercer or more frequent? This chapter sets the foundation for understanding the hurricane's origin, a vital step before exploring how those origins are changing in a rapidly warming world. As we delve deeper into the enigmatic heart of a hurricane, we encounter one of nature's most fascinating paradoxes: the eye of the storm. This central calm amid chaos is not just a geographical feature but a window into the hurricane's immense power and complex dynamics. Understanding the eye, the storm's serene center surrounded by devastating fury, offers unique insights into the hurricane's behavior and its capacity for destruction. The eye forms as part of the larger structure of the hurricane, which includes the eye wall, the ring of towering thunderstorms immediately encircling the eye. While the eye is often depicted as a peaceful clearing in the tempest, it is the surrounding eye wall where the storm unleashes its most intense forces. Here, wind speeds reach their peak and rain falls with a relentless ferocity. It is this ring of fury that drives the hurricane's destructive might. Inside the eye, the atmosphere behaves differently. This region spans anywhere from 20 to 50 miles in diameter and is characterized by relatively clear skies, light winds, and a notable drop in pressure. The calm is deceptive. It is the result of intense air circulation patterns where air rapidly rises in the eye wall and descends gently in the eye itself. This descending air warms and dries, suppressing cloud formation, which explains the unusual clarity found in the eye compared to the rage just outside it. But the eye's calm is temporary and surrounded by chaos. As the eye passes over a location, residents may witness an eerie stillness and sunlight, lulling many into a false sense of security. This deceptive peace is dangerously misleading, for on the opposite side lurks the other half of the eye wall, often bringing a return of violent winds coming from the opposite direction. These winds can sometimes double the destruction as buildings weakened on the approaching side are battered again. The eye's size and shape can vary significantly depending on the hurricane's intensity and maturity. Some powerful hurricanes develop what is called a pinhole eye, which can be as small as 3 miles in diameter but is tightly compacted, signaling intense winds swirling tightly around the center, a sign of a particularly fierce storm. Other hurricanes display larger, more defined eyes that suggest a mature and stable storm system. Satellite imagery and radar technology have revolutionized our ability to observe and understand the eye in real time. These tools enable meteorologists to track eye formation, monitor changes in its diameter or symmetry, and even foresee phases when a hurricane might strengthen or weaken. The eye's appearance and behavior can serve as vital clues. For example, when the eye begins to shrink, it often indicates rapid intensification, as air circulation tightens and wind speeds increase. Interestingly, not all hurricanes have a well-defined eye. Early in development, storms may be disorganized with cloud patterns scattered and without a clear center. As the storm intensifies and organizes, the eye forms, marking the transition from a tropical storm into a powerful hurricane. Beyond its meteorological significance, the eye has also captured human imagination for centuries. The eerie calm in the heart of a dangerous storm has inspired art, literature, and even fear, symbolizing the fragile balance between order and chaos. For those who have experienced hurricanes firsthand, the eye represents a moment of surreal calm that vividly contrasts with the storm's overall brutality. Despite the eye's transient peace, it also plays a crucial role in the hurricane's energy cycle. The descending air brings high pressure relative to the rapidly falling pressure in the eye wall, which helps sustain the storm's circulation. This delicate balance reinforces the vortex and fuels the continuous inflow of moist air from the ocean's surface that as hurricanes approach land, the eye's passage becomes a crucial moment in the disaster's timeline. Emergency responders often use the timing of the eye's arrival and departure to manage evacuations and safety protocols. People caught unaware by the eye's calm risk danger from the sudden return of the storm's violent eyewall winds. The eye is much more than just a quiet center. It is a dynamic core that holds the storm together, driving its devastating power while offering a glimpse into the complex physics at play. The peaceful eye contrasts starkly with the chaos it surrounds, embodying the hurricane's fierce duality. Throughout human history, hurricanes have left marks far beyond the immediate devastation of wind and rain. These colossal storms have altered economies, reshaped cities, influenced migration patterns, and transformed the course of entire regions. Understanding the stories of the most iconic hurricanes offers us not only vivid examples of nature's might but also lessons in resilience, adaptation, and the evolving relationship between humans and the environment. One of the earliest and most devastating hurricanes recorded in modern history is the Great Hurricane of 1900, which struck Galveston, Texas. At the time, Galveston was a bustling port city and a thriving economic hub on the Gulf Coast. On September 8, 1900, a massive Category 4 hurricane barreled toward the island city with winds estimated at over 130 miles per hour. Despite warnings from the U.S. Weather Bureau, the city was largely unprepared for the sheer scale of the disaster. The storm surge, a towering wall of water driven ashore by the hurricane's force, inundated much of the island, destroying homes, businesses, and infrastructure. In mere hours, the city was transformed, with entire neighborhoods wiped away and debris scattered miles inland. Tragically, more than 8,000 people perished, making it the deadliest natural disaster in U.S. history. The catastrophe exposed critical failures in hurricane preparedness and forecasting technology of the era, and it spurred significant advancements in meteorology and coastal engineering. Galveston's rebuilding effort became a symbol of human resilience. The city constructed a massive seawall, raised the elevation of buildings, and improved early warning systems, lessons that would inform hurricane response strategies worldwide. This hurricane immortalized the unpredictable power of nature and underscored the necessity for science and infrastructure to mitigate future risks. Fast forward to the 21st century, Hurricane Katrina in 2005. This storm is etched into global memory as one of the most catastrophic urban disasters. When Katrina made landfall near New Orleans as a Category 3 hurricane, it exposed the vulnerabilities of a modern city protected by fragile levees. The storm surge overwhelmed the city's flood defenses, resulting in widespread flooding that devastated neighborhoods and displaced hundreds of thousands. Katrina's impact went beyond physical destruction. It sparked critical discussions about social inequality, emergency preparedness, and government response. Many of the hardest-hit areas were home to marginalized communities, revealing systemic disparities in disaster resilience and recovery aid. The slow and chaotic response galvanized community activism and led to reforms aimed at improving disaster management at local, state, and federal levels. The lessons from Katrina highlight how hurricanes are not just natural events but social phenomena shaped by human decisions and policies. Understanding these factors is essential to building more equitable and effective resilience. The historical impact of hurricanes also stretches beyond the United States. In 1780, the Great Hurricane of the Caribbean struck during the height of European colonial rivalry. Regarded as the deadliest Atlantic hurricane on record, it destroyed numerous ships and killed an estimated 22,000 people. The storm had strategic consequences, dramatically affecting naval power and colonial ambitions in the region. These historic hurricanes taught societies to adapt building techniques and urban planning, recognizing that nature's forces demand respect and preparation. From wooden structures elevated above flood-prone areas to the modern use of storm-resistant materials, humanity has continuously evolved its relationship with hurricanes, not only to survive but to thrive. Today, advances in satellite technology, computer modeling, and communication systems allow forecasts with unprecedented accuracy, giving communities vital lead time to evacuate and prepare. Yet the challenge remains immense as climate change intensifies storms and raises sea levels, which increase the threat of flooding. Reflecting on these past hurricanes reminds us that while we cannot stop nature's fury, knowledge, science, and collective action are powerful tools to reduce harm. These historic storms are more than tragedies, they are the foundation for our ongoing efforts to understand, forecast, and live safely alongside hurricanes. As the world faces unprecedented environmental changes, one undeniable fact emerges: our climate is warming. This warming dramatically influences hurricanes, reshaping how they form, intensify, and impact our lives. To understand the future of hurricanes, we must explore the intimate relationship between climate change and these magnificent, terrifying storms. The increasingly warm oceans serve as the primary catalyst. Hurricanes are essentially heat engines, fueled by moisture evaporating from ocean surfaces. As global temperatures rise due to greenhouse gas emissions, ocean surface temperatures have increased steadily over the past century. This extra heat provides hurricanes with more energy, allowing them to grow stronger and sustain higher wind speeds. Scientific studies reveal that the strongest hurricanes are becoming more frequent, with an increase in Category 4 and 5 storms observed globally. These intense hurricanes devastate coastal communities with supercharged winds, torrential rains, and towering storm surges. Additionally, warmer ocean water layers deepen the vertical extent of heat, permitting storms to maintain intensity even as they move further north or into unusual regions. Another significant impact of climate change is on rainfall associated with hurricanes. Warmer air can hold more moisture, which hurricanes then release as heavy precipitation. This leads to greatly amplified flooding during storms. The notorious Hurricane Harvey in 2017 exemplifies this, dumping over 60 inches of rain in some areas and causing historic floods. Scientists attribute this extreme rainfall event largely to increased atmospheric moisture fueled by a warming climate. Sea level rise compounds the risk from hurricanes. Melting polar ice and thermal expansion of seawater elevate coastal waters, intensifying storm surge flooding as hurricanes push ocean water inland. Coastal cities once protected by natural barriers or levees face heightened vulnerability to inundation, threatening infrastructure, homes, and lives. Moreover, the behavior of hurricane movements appears to be shifting. New research points to a slowing of hurricane forward speeds, causing storms to linger longer over affected areas. As a result, rainfall can last for days rather than hours, extending flood durations and potentially compounding damages. This slower progression exacerbates the storm's destructive impact despite potentially reduced landfall wind speeds. Climate change may also influence hurricane formation patterns. Altered atmospheric circulation, changing sea surface temperatures, and variations in wind shear may affect where and when hurricanes arise. While overall hurricane frequency may not drastically increase, the proportion of powerful storms and their geographic distribution is likely to change, presenting new challenges for prediction and preparedness. In response, the scientific community has intensified research efforts to unravel these complex interactions. Advanced climate models and increased satellite monitoring help forecast hurricane behaviors under various warming scenarios. These tools assist in improving early warning systems, evacuation planning, and infrastructure design to better withstand future storms. Understanding the climate connection empowers us to anticipate and adapt to these evolving threats. By recognizing that hurricanes are not static phenomena but dynamically linked to our changing planet, societies can prioritize mitigation efforts to reduce greenhouse emissions and develop resilient strategies to protect vulnerable communities. In the face of the hurricane's unrelenting power, the human spirit shines brightest. Across the globe, individuals and communities have endured unimaginable hardship wrought by these storms, yet time and again they rise, rebuild, and innovate. This chapter delves into the inspiring stories of survival, resilience, and human ingenuity in the shadow of hurricanes, revealing how communities have overcome disaster and how science and technology are transforming the battle against nature's fury. Consider the stories of survivors who withstood hurricanes that seemed unstoppable. In 2017, during Hurricane Maria's devastating assault on Puerto Rico, countless lives were uprooted as the island faced widespread destruction. Power outages, flooded homes, and disrupted healthcare systems. Yet amid the crisis emerged tales of extraordinary courage. Neighborhoods came together, sharing resources, rebuilding homes with improved designs, and innovating through grassroots efforts to restore communication and electricity. These stories reflect more than survival. They highlight adaptability and community solidarity. Beyond individual bravery, emergency responders, scientists, and engineers work tirelessly to prepare for hurricanes and reduce their consequences. Advances in forecasting technology now provide earlier warnings and more precise storm tracking, allowing more time for evacuations and preparations. Projects like the Hurricane Hunter aircraft flying into storm eyes deliver critical data for modeling hurricane strength and direction, revolutionizing disaster response. Innovation also extends to building science. Coastal architecture has evolved in response to lessons learned from past disasters. Elevated homes, reinforced structures, and flood-resistant materials are increasingly standard in hurricane-prone areas, greatly reducing property damage. In cities like Miami and New Orleans, seawalls and storm surge barriers mitigate flooding risks, though ongoing climate challenges demand continuous adaptation. Communities themselves have adopted smarter approaches. Programs focused on public education about hurricane preparedness, emergency kits, and evacuation routes save lives annually. Social media and mobile apps now play crucial roles in disseminating real-time alerts and connecting people with resources during storms. On a larger scale, international cooperation and data sharing enhance global capabilities to monitor and predict hurricanes. Satellite constellations and supercomputers enable climate scientists to refine models, understanding not only current storms but also projecting future patterns influenced by climate change. Yet challenges remain. Recovery after major hurricanes can take years, and vulnerable populations often face greater risks and slower assistance. The human spirit's resilience is powerfully tested in these contexts, prompting calls for more equitable disaster policies and inclusive planning. These stories of survival and innovation reveal an inspiring truth. While hurricanes